Hello, calculus student. This video is for chapter 3.5, derivative of trig function, part 2. So in part 1, we talk about how to do a derivative of a given function that involve sine, cosine, and we can also do it with power rule. The important things to know is after you do a derivative, you have to simplify. Okay. So usually after we do derivative, we do higher derivative. Now we do tangent line and applications. So tangent line problem, if I have a function f of x equal to secant x, just very simple, secant x. We know secant x was a function that is a reciprocal of cosine. So we can just, so cosine was like this, right? And then the secant x would be, the graph itself would be like the U shape. So yeah, whenever there is a, I think this actually meet together. So when cosine is 1 or -1, that would be the same as secant. And when cosine is negative, you have vertical asymptote, so it's like this kind. So we want to find, like, at a certain point, pi over 4 here, what is the equation of the tangent line? So equation of the tangent line depends on slope. Right? So first of all, we need to find slope of the tangent line. Slope of the tangent line is f prime of x, right? Prime of x equal to slope of the tangent line, which is a derivative function. So let's do a derivative of secant x. If f of x, so f prime of x would be do the differentiation of secant x. And then if you still remember the derivative rule for secant x is secant x tangent x. So it's a product of two things. So f prime at pi over 4, that would be the slope of the tangent line. So it would be secant pi over 4 times tangent pi over 4. Tangent pi over 4 is 1. Secant pi over 4 is 1 over cosine pi over 4. Cosine pi over 4 in the unit circle is root 2 over 2. So reciprocal of root 2 over 2 is root 2. Okay, and then times tangent pi over 4. This means you plug it in. So in the unit circle, remember cosine is here. And the coordinate is root 2 over 2, root 2 over 2. So it's root 2 over 2 cosine pi over 4 equal to root 2 over 2. The reciprocal of it would be 2 over root 2. 2 over root 2 is actually root 2. Okay, tangent is 1. So the slope at pi over 4 is root 2. So to find the equation of the tangent line, we need to find a point, right? Slope and a point. Point is pi over 4 at x. What is secant pi over 4? Secant pi over 4, we already evaluate, is root 2. So we have point and we have slope. Okay, this is m. Slope is root 2, point is this. So the equation is y minus y1 equal to m root 2. Usually a slope is a number, but in this case it's rational. It's root 2 over 1 times x minus pi over 4. So if you multiply everything out and simplify, the equation is y equal to root 2x plus root 2 plus root 2 pi over 2. You cannot simplify this, but that is the equation of the tangent line. The next, so you need to know how to do the unit circle, plug in, okay, use the unit circle. And also you need to not just read sine and cosine, but after you read sine and cosine, be able to do this. The last one is application. So its application is movements of particles. So it's a position function s of t. It tells where the position of a particle is or object is. It's 2 sine t minus t. So this is the equation that tells where it is located. Is horizontal or is a one-dimensional movement. When is the particle at rest? At rest means it's not moving. And we're only looking at t between 0 and 2 pi. Anytime we use sine and cosine for a function, to model, the inside is not a degree. I think we talk about those is radian. So it would be t would be between 0 to 6.28, right? Pi is 3.14, around 3.14 is about 6. So when is it at rest? At rest means velocity is equal to 0. How do I find velocity? As f s prime. The derivative of the displacement is v of t. So we do a derivative of this. So f prime of t would be d dx of, oh, it's actually t because it's not x anymore, of 2 sine t minus t. So the first we apply the derivative rule for sine will be 2 cosine t. Apply the derivative for t is minus 1. So when it's at rest, this would be equal to 0, right? So s of t, s prime of t equal to 0 is at rest. So we would solve 2 cosine t minus 1 equal to 0. So that is cosine t is equal to 1/2. So in the unit circle, because from 0 to 2 pi is the unit circle, where is cosine t equal to 1/2? We know this one is not, we know it is here, right? So with 3 is pi over 3. At pi over 3, we have a 1/2 with 3 over 2. So this is the cosine equal to 1/2, that's pi over 3. Is there another one? It's over here. It's 5 pi over 3. Also 1/2 but negative with 3 over 2. So our t would be, it is at rest at pi over 3 and also 5 pi over 3. So you see how when you solve a trig function, you would solve a work problem. So at time, pi over 3, and try pi over 3, second, I think, I didn't say anything about the unit, time unit, could be hour, it could be whatever that they want, they didn't say. So this would be the particle is at rest. So we have 7 minutes. I want to do one more higher order derivative for trig. Trig is a little difficult for a lot of people for doing trig function, a derivative function of trig. Okay. So just want to do one more. I was thinking I should do one more. So let's say we have a trig function of, because after you do it, you have to simplify. If I have a function or a formula that is a secant x, because when I would look at secant x, it reminds me. If I do dy dx, what would happen? It will be secant x tangent x, right? If I do one more, what would happen? If I do d square y dx square, that means I have to do a derivative, the first derivative of the first derivative. Secant x tangent x. And what would this be? This is a product, right? So we'll do the f fig and gif again. F equal to secant x, g equal to tangent x, and then f prime. What is f prime? Oh, we do it again. Secant x tangent x. What's g prime? G prime is secant square x. Secant square x. So now when we do this, it would be fake. Secant x tangent x times fake, right, from tangent x. And then plus a gif, g prime. So it'll be secant square. Where's my pen? I can find it. Okay, secant square. And then secant x. So you can see that there's a lot of secant and tangent. So this becomes secant x tangent square x plus secant cube x. If I factor secant out, because both of them have secant x, I would have tangent square x plus secant square x. Can I actually further simplify it so I only have one trig function. Still remember, if I have tangent x, tangent square x, so notice that tangent square x plus 1 is equal to secant square x. So I can change this into a secant by substituting secant x, secant square x minus 1, right? If I minus 1 both sides, I have tangent square x. And then I plus secant x. So what do we have? If we simplify the whole thing, it would equal to secant x 2 secant square x minus 1. And we have everything like in secant. Okay, so this is just a demonstration of when we do trig functions, derivative, sometimes you have to use the identities. So please get familiarized with your trig identities. So that's all of 3.5.